Welcome back. In this video, we'll find out what data looks like and where we can find it. When you think of data, you probably think of something like this, a table with a lot of numbers, or maybe you have some kind of graph in your mind. While this is one of the most common forms of data, there are also other forms you might not immediately consider. Take image and text for example. Digital images have many tiny pixels, each with its own colour value. These pixels and their colour values can be used as data to detect what can be seen on the image automatically. Social media posts, emails, and reviews are all text that can be analysed to answer specific questions. For example, we could do a Twitter analysis of a soccer match to find out whether people found the match exciting or not at all by looking at the words they used and their frequency. Other forms of data include network and spatial data. Network data can answer questions like, are many social connections linked to happiness? Or spatial data, which can be used to answer questions such as, where is the best place to open a new coffee shop? Nowadays, a lot of data is publicly available. This is especially the case with government or non-profit data. Your local government likely also provides data on social or economic topics on their website. APIs are another good source of data. APIs act as a go-between to collect specific data on the internet. The Twitter API, for example, allows you to quickly and easily collect tweets about a certain subject. Another important data source is internal data. This is data that is shared to you or your business under specific conditions. This data is not publicly available and typically is protected by privacy regulations. For example, customer data like age or how long they've been a customer, transaction data like the sales number for a certain product. Data can also come from a website, like the number of visitors each day or which part of the website gets the most clicks. Lastly, surveys could be used to gain specific data on a certain topic. For example, satisfaction with a specific product or service. Now that you know how to recognize data and find good data sources, let's practice. In this video, we will discover the ins and outs of some of the most common data types. We'll often have to use different types of data to get a complete picture in an analysis. The data type mainly affects how to collect the data, how to store the data, and how to analyze the data. We need to make two main distinctions: whether the data is structured or unstructured, and whether the data is qualitative or quantitative. Structured data is data in tabular form, organized in rows and columns. Because it has such a strict structure, it can easily be read and used by a computer. It is typically stored in relational databases. Unstructured data, on the other hand, has no predefined structure. Because of that, more pre-processing is necessary before this type of data can be used in an analysis. Unstructured data is typically stored in document databases. Structured data is the most recognizable type of data. It is likely what would come first in your mind when thinking about data. Spreadsheets, like Excel, are a common example. It consists of sheets of data arranged neatly in rows and columns, which can then be used for calculations. Unstructured data has no predefined format, and so can come in many forms. Common examples are images, videos, sound files, and text like email, social media posts, or ratings. The second important distinction is between quantitative and qualitative data. Quantitative data describes something numerically. It can be measured or counted, like the distance between your home and work. Qualitative data, however, describes something with categories that can be observed, like the colour of your eyes. Unlike quantitative data, calculating statistics and analysing qualitative data is more restricted. For example, we can calculate average length, but the average colour would not make much sense. If we were to describe ice cream quantitatively, for example, we could measure or count things like the number of ice cream scoops, the minutes before the ice cream started to melt, or the length of the cone. If, on the other hand, we would qualitatively describe ice cream, we could talk about the flavour of the ice cream, the colour, or whether we want a cone or a cup. Time to put your new knowledge about data types into practice. In this video, we'll learn about how to keep track of our data with the help of databases and other tools. A database is a general loose term for the storage of data. A database is typically managed with a database management system. This is a software that allows the user to store, retrieve, and access the data. There are several specialized types of databases. A document database stores unstructured data. Relational databases store structured data. These are called relational because they usually store multiple databases that are related to each other. For example, one data table contains the sales data of a particular product. Through the customer ID, another data table can be accessed to get the complete customer data. Another important distinction is a data warehouse versus a data lake. A data warehouse contains processed, organized data in preparation for further analysis. On the other hand, a data lake is used to store raw data that has not been prepared yet. Typically, designing and optimizing database systems is the responsibility of a data engineer. They help to ensure that the necessary data is available and ready to be used. A lot of data is stored in the cloud nowadays, which means that data is stored on remote servers and accessed over the internet. A specialized third party typically provides these services. Storing data on the cloud instead of on-site servers is more flexible and cost-effective. Still, it can be problematic with sensitive data, as you would be dependent on the security of the third-party provider. The purpose of pipelines is to move data from one database to another. This process can be automated using the ETL framework. ETL stands for Extract, Transform, Load, referring to the different processing steps. Making use of pipelines ensures the availability of up-to-date and accurate data. Now that we have all the data in our databases, it is time to get our data ready for analysis. Retrieving data from databases is also called querying. The industry standard for querying is SQL, which stands for Structured Querying Language. Further analysis can be done with programming languages like R and Python. Another way to leverage the data available in databases is through dashboards. Databases are very technical, but dashboards offer a non-technical alternative to collecting, managing, and sharing data between teams. A dashboard provides information at a glance, typically metrics such as key performance indicators to follow up on business goals. A dashboard has access to the data by being linked to a database. Dashboards typically show data in a very visually appealing way. They can be used for multiple purposes, including doing basic analysis or communicating. Creating and managing dashboards is typically the responsibility of a data analyst. Enough theory, it's time to practice. In the final video of this chapter, we'll discuss some common data problems. Dirty data is incorrect, incomplete, or inconsistent data. It can be caused by human error, technical issues, or selective data collection. Realistically, starting out with data problems such as these is usually unavoidable. You cannot ignore dirty data, as if not resolved, it can eventually lead to data that is not representative of what we are trying to analyse, leading to flawed analysis and wrong conclusions. Compare it with a dirty window. If it is very dirty, you would not be able to see clearly through and see what's on the other side until you clean it. Data errors consist of incorrect or inconsistent data, for example, typing errors, or dates in the wrong format. They are typically caused by recording errors. They can easily be resolved if the original value or valid format is known. Otherwise, the data points in question need to be dropped. We say that data is missing if some data points are left blank. For example, if you conduct a survey and some respondents do not answer certain questions. Missing data can be especially problematic if many data points are missing or if there are underlying patterns in the missing data. For example, if only older adults or some other group did not answer the survey questions. Depending on the severity of the problem, the data can be dropped or imputed. The latter is a technique that allows us to estimate statistically what the missing values could be. The data can also take on real-world characteristics, as we use real-world data. This means that societal bias can be reflected in data bias. Like extremely dirty data, severely biased data can lead to unrepresentative data and results. Unfortunately, data bias can be hard to detect and resolve. The best way to counter data bias as much as possible is to ensure a solid data collection process and be aware of potential bias in our conclusions. Lastly, explainable AI techniques can help to more easily detect possible bias during the analysis phase, as they make the output of models more interpretable. Data cleaning consists of a set of techniques to counter data problems. It is an important preparation step for any analysis, so make sure to allocate the necessary time. Not all data problems are solvable, however. For example, if you can't know the right value of incorrect data. Even if the data is severely compromised due to data problems, it is always possible to do some kind of analysis. For example, perform a descriptive analysis to point out the data problems and use that to improve the data collection process. Time to practice.